Okay, let's look at section 2.6, which talks about absolute values. For the first set of notes, we're just going to talk about absolute values when you have only one absolute value in the equation. On Monday, we're going to talk about when you have multiple absolute values in an equation. So we'll look at that. Okay, so an absolute value, you know, is always positive. The basic absolute values are that if you have the absolute value of k, where k is greater than 0, then x equals k and minus x equals k, which gives you the solution set, and you have two solutions, k and negative k. If the absolute value of x equals 0, then the equivalent equation is x is equal to 0, and the solution set is 0. If the absolute value of x equals negative k, then the solution is the empty set. There is no solution to that problem. And we talked about this a little bit earlier in the year. If you have the absolute value of x minus 7 equals 2, this generates two equations, just like in the equivalent equations. The first one is that x minus 7 is equal to 2, and the second is that the opposite, x minus 7, is equal to 2. Now, I think in middle school, something like this, they tell you that you get two equations, x minus 7 is equal to 2, and x minus 7 is equal to negative 2. And although that usually works, that's not mathematically what is positive or negative. Mathematically, what can be positive or negative is what's inside the absolute value sign. So we're going to put the negative sign where it belongs, and that's on the value inside the absolute values. So for the first one, we're going to add 7 to both sides, of course, and get x is equal to 9. And then we have minus x plus 7 is equal to 2, minus x is then equal to negative 5, so x is equal to 5. So the solution set, x is equal to, in set notation, 5, 9. Okay. The next one, 3x, the absolute value of 3x minus 5 is equal to 7. So again, 3x minus 5 is equal to 7, and then the opposite, 3x minus 5 is equal to 7. Remember to use the parentheses and distribute that negative sign. So I get 3x is equal to 12, so x is equal to 4. Here I'm going to have minus 3x plus 5 is equal to 7. So negative 3x is equal to 2, so x is equal to negative 2/3. So the solution set, x is equal to negative 2/3 and 4. Okay, so the next one adds another level of complication, because inside the absolute value you have a multiplier and then you have addition. So when you look at that, how do you handle setting that up? The first one, of course, is going to be, actually you can just go ahead and, inside the absolute value signs, go ahead and multiply 2x minus 12 plus 7 equals 0. So then you have the absolute value of 2x minus 5 equals 0. And then you can take that and set up your two equations. So 2x minus 5 equals 0, and then the opposite, minus 2x minus 5 equals 0. So 2x is equal to 5, x is equal to 5 halves, and minus 2x plus 5 equals 0, so minus 2x is equal to minus 5. So here, x is equal to 5 halves, so we only have one value in our set, and that is 5/2. Okay. The next one, number 4, the absolute value of x minus 9 is equal to negative 6. So if you look at that and you go back up to our definitions, what happens when the absolute value is equal to a negative number? It's equal to a negative number, that's the empty set. So there is no solution for that problem. Okay, next, this time we have minus 5 times the absolute value of 3x minus 7 plus 4 equals 14. So what you want to do is start to isolate the absolute values. So start by subtracting the 4 from both sides. So you have minus 5 times the absolute value of 3x minus 7 is equal to 10. Because that 5 is outside of the absolute value signs, you can divide both sides by that 5. So you actually have the absolute value of 3x minus 7 is equal to negative 2. And look, there again we have an absolute value equal to a negative number. We know that's not possible, so the solution is the empty set. Okay, so remember, for an absolute value equation, you should get the empty set or a solution set containing 1 or 2 values. Now we're going to take a look at the inequalities. So the inequalities, the absolute value of x is greater than k, means that x is greater than k or negative x is greater than k. And when you get the solution set, now instead of 1 number, 2 numbers, or the empty set, you are going to get either 1 region or 2 regions or no regions. So in this case, we're going to get 2 regions. So if we graph this, okay, so here's our graph. Here is minus k, here is k. So this looks like from minus k to minus infinity and plus k to positive infinity. The next one, very similar. The absolute value of x is greater than or equal to k. So now x is greater than or equal to k, or negative x is greater than or equal to k. And so for this solution set, just like the previous, the only change is now that k and negative k are both included. So we use the brackets. So that's that one. This is this one. So at minus k to negative infinity, and then positive k to positive infinity. Okay, the next one, the absolute value of k is less than, this time it's less than, the absolute value of x is less than k. So x is greater than negative k and less than k, so you end up with 1 region. Okay, on this number line, I have k, minus k, and I have k. So the solution region is here between minus k and k. The next one, the absolute value of x is less than or equal to k. So therefore x is greater than negative k, less than or equal to k. So that's greater than or equal to negative k, and less than or equal to k. The region looks similar to the one above, except this time we will have brackets. So for this, the graph looks like minus k to k, and the solution region is between those two. Okay, so now when we look at the absolute values, we can think about those absolute values as ands and ors. So if you get two regions, the absolute value of x is greater than k, or negative x is greater than k, you can think of that as an or. And of course, then when we add the equal sign, that is an or as well. And then the absolute value of x is less than k as an and, where they are both true. So let's look at these examples. The absolute value of x minus 9 is less than 2. So this you can think of as an and. You're going to have x minus 9 is less than 2, and then negative x minus 9 is less than 2. So x is less than 11, and minus x plus 9 is less than 2. Minus x is less than negative 7, so x is less than 7. Greater than 7, I'm sorry. I divided by a negative 1, so I have to reverse my inequality, so x is greater than 7. So on the number line, here is 7, here is 11. If x is less than 11, I have this line. X is greater than 7, I have this line. So the region is between 7 and 11, and in interval notation, that's 7, 11. Number 2 is an or. Number 2 is an or. Okay, let's take a look. I have 3x plus 5 is greater than 2, and then minus 3x plus 5 is greater than 2. So when I solve this, 3x is greater than negative 3, so x is greater than negative 1. Over here, minus 3x minus 5 is greater than 2. Minus 3x is greater than 7, so x is less than, let's do that again, less than negative 7/3. So on my number line, I have negative 1, negative 2, and negative 3. So x is greater than negative 1. So that region. And then x is less than negative 7/3. And the region from negative 7/3 to negative infinity. So we're looking at the union of minus infinity to minus 7/3 joined with negative 1 to positive infinity. Number 3, again, when I look at this, I want to decide if I have the union or the intersection, or an and or an or. This is an and. And the reason you want to look at that is it helps you predict if you're going to get one region or two regions in your solution. So 5 minus 3x is less than or equal to 6, minus 5 minus 3x is less than or equal to 6. So minus 3x is less than or equal to 1. X is greater than or equal to negative 1/3. And I have minus 5 plus 3x less than or equal to 6. So 3x is less than or equal to 11. So x is less than or equal to 11/3. So now, on your number line, and you can write that as a compound inequality, x is greater than or equal to minus 1/3, less than or equal to 11/3. On the number line, here is minus 1/3, here is 11/3. The region that satisfies that inequality is between, oops, yes, there is an equal sign there, is between negative 1/3 and 11/3. So this is the region that satisfies that inequality. Same as before, when you have a number outside of the absolute value signs, you can just go ahead and subtract that from both sides. So we have the absolute value of 7 minus 2x is greater than or equal to 0. So I have 7 minus 2x is greater than or equal to 0. And then the opposite of that, minus 7 minus 2x is greater than or equal to 0. So minus 2x is greater than or equal to 0. So x is less than or equal to 0. Remember, you're still dividing by a negative number, so you still have to reverse that inequality. Next, we have minus 7 plus 2x is greater than or equal to 0. So 2x is greater than or equal to negative 7. So x is greater than or equal to negative 7/2. So when you look at this, you have two regions, actually, at 0 and at negative 7/2. So the region that satisfies this inequality will be 0, less than or equal to, so here is one, and here is the other. For that 4. So if that's the case, then the region that satisfies that inequality is going to be, let's see, oh, we didn't even have to do all of that work, actually. We did a lot of work for nothing. Let's go back to this. Sorry, I wasn't thinking when I looked at this. When I subtract 3 from both sides, I have the absolute value of 7 minus 2x is greater than or equal to 0. So now think about this. Is there any way the absolute value of 7 minus 2x can be less than 0? Is there any way it can be less than 0? Substitute any value of x. The answer is no. The absolute value is always positive. Therefore, this will always be true, and therefore all real numbers are solutions to this absolute value inequality. So in interval notation, anything from negative infinity to positive infinity would make that true. Okay, last one, number 5. 5x minus 12 is less than or equal to negative 2. We look at that, and again, we just have to think about some of these before we actually start doing some of the work, because the absolute value will always be positive. There's no absolute value out, or there's no negative sign out front of that absolute value. So therefore, this one is the empty set. There is no solution to that problem. Okay, application problem. The water temperature in a certain manufacturing process must be kept at 143 degrees. The computer is programmed to shut down the process if the water temperature is more than 7 degrees away from what it is supposed to be. For what temperature readings in this is the process shut down? So if you look at this, the absolute value of x minus 143 has to be greater than 7. So you have x minus 143 greater than 7, and then minus x plus 143 is greater than 7. So when x is greater than 150, or when x is less than 136, then the computer would shut the process down. Okay? Now, on Monday, we're not going to do this today. We're just going to do regular absolute values. On Monday, we're going to talk about what happens when you have an equation with multiple absolute values. Keeping in mind, if you want to think about this a little bit, each absolute value generates both a positive equation and a negative equation. And we'll talk more about that on Monday. Have a nice weekend.